Hello, don't let appearances fool you. This is a sum of squares. The only problem is if we use our complex factorization of sum of squares, I get x squared plus I and x squared minus I. Not a problem so far, but let's go ahead and solve these algebraically. X minus I equals 0. That means x squared equals I. And then when we square root, what is the square root of I? Well, let's go ahead and use our polar form. We've got I would be equal to e to the natural log of I, and we're square rooting this, so that would be times 1/2 here. Now the natural log of I would give us pi over 2I. That would give us e to the pi over 4I. Now with a modulus of 1 and an argument of pi over 4, this would be equal to root 2 over 2 plus root 2 over 2I. So the square root of I would be this thing right here. Now remember, we need the plus and minus of that, and we're also going to get effectively the conjugates from here. So our final solution set is x equals root 2 over 2 plus or minus root 2 over 2I, and then x equals negative root 2 over 2 plus or minus root 2 over 2I. And that is the final answer.